All right. So thanks, everybody. This is our updates, which actually is really good. We have these 3-a-year meetings because it kind of focuses or forces me to put together in just a few slides these updates. But that said, we've had a lot of these updates. And so the one for today looks at what happened since our update last September to January. Which of course for many of us had a lot of good holiday time, but we got a lot of work done. So I'll give you a general project update, talking through some areas, and then we'll look at the 3-year roadmap work streams update. So we put that on the table last time, and we will look at it, what's happened around that, and key focus areas for 22. We'll talk about this Gemini ecosystem pathway group launching, and then we have some topics. One is topics of interest, but now we have 3 of these tables that we're wrestling with. So how does that work? I'll give you an update on the requirements interoperability, model-centric, regulatory-ready kind of aspects of the project, and then in a further up and further in notion, these 2 topics. One is the MDC 2.0, and Michael Fahn is going to give us contemplations from his perspective on the pointy end. It's an open discussion, though. We started this last September and thinking about next generation, so the years ahead, not the immediate ahead. And then also David Gregorchek will talk about gRPC protobufs, the work that's ongoing there. So that's kind of what's ahead today. But to be sure, we have a lot of these updates. And so they're posted generally at the URL at the bottom. I have that library page we created last year. And so this is cumulative. I'm trying not to repeat all of that stuff. We actually have recordings for the last 2 of these. Today's session will also be recorded and posted on that same page. So hopefully it helps us save time and stay focused. But a lot of good stuff in there. So here's a bunch of bullets as to what have we been up to and actually move forward on since our meetings last September. One is, last September we put on the table the Gemini 3-year roadmap, and that continues to evolve. So what does SDPi 1.0 look like? What are we looking to do in this year and then that year? What does that sequence look like? It's a big area. We've kind of scoped out this large space, but the roadmap helps us work through that, especially for those who are actively looking at real-world products around this, actually thinking about implementing this and taking that forward. So a lot of detailed planning remains. I think I have a slide on that or 2 on updates, but we've been working on that and evolving that. We've had plugathons. So right, David, we had a very successful plugathon early December, and I don't know, I have a little bit that we can look at for that, and then also we have one that's currently being planned for the first week of March, and we're hoping to have them every other month, so about 6 this year, but at least 5 and maybe 6 this year. So those have been continuing on and have been very helpful and successful. I think since September we had one in October and one in December. So 4 and 5 were completed. We initiated that Catalyst Study program. So remember, IHE Catalyst, we talked about that in September, is really the owner now of the Gazelle platform, test platform for IHE, as well as a lot of the test tooling that's integrated into that, and the whole conformity assessment process and how that works. They're kind of the entity that does it. They took over for IHE services. So we've been in discussions with them around what exactly does it look like, especially over the next 2-3 years, for being able to support SDC, SDPi, and FHIR in these in connectathons, in maybe projectathons, toward product conformity assessment. So we've initiated a study project with them, dumped a lot of information on them. I think they were a bit overwhelmed about this whole device space and interoperability around devices. And we have a study that's actually coming towards the end of it, we hope. So my hope is that within sometime in middle of February, we'd be able to integrate the results of this study project into the roadmap and really be able to paint a clear picture for what the conformity assessment aspects look like. I'll talk a little bit about that more later. We've been evaluating sustainable business model options around this Gemini project. Again, I mentioned before, Gemini is an IHE, joint IHE-HL7 effort, and we've actually one of the few projects that have used this to really good ends. I mean, it's really helped us having that. But now that HL7 has re-engineered or re-envisioned, I think they call it, and is actually also has this new executive positions that we've talked about in the reorganization. How will that impact the Gemini project? And what do we actually need as a community to be able to support the tooling that'll be necessary, the events that'll be necessary, all of the work streams around this for years to come? And so those business model discussions, if you will, have been ongoing, and I anticipate we'll bring those to closure with a real clear action plan just in the next couple months, definitely in Q1. So we've been working that, moving that forward. The RIMCRR initiatives have been refined and advanced, have some slides on that. We've showcased discussions, especially on HIMSS 23 around the silent ICU, silent point of care use case. So that's gained a lot of momentum. So you'll see some stuff in the HIMSS 22 showcase, although it'll be interesting. Everybody's still kind of holding their breath as to who will actually be able to travel and make it to that showcase. But definitely clear sight set on the HIMSS 23 showcase. And once you have that, you back up then and say, okay, technically, what do we need to have in place? What do we need to have? What are the parts for our plugathons and connectathons to actually get all the pieces put together for that showcase? So there's been a lot of discussion and around that, and it's going to only increase. We have had the Madeira profile activity. Remember, I reported in September the transition from the APL work there that was concluded that program the end of June, and now we've started up every month we have a web meeting, and we're actually working on a topics of interest table specifically for that, of areas that need to get resolved. And this work, as I've said before, is especially relevant to the ecosystem pathway discussions, because I think a lot of what will be formalized in the Madeira profile are items and issues and challenges that will be surfaced during the EP discussions. So that work is ongoing. It's not at a high intensity level, but it is continuing. And anybody who's interested in that, let me know. We have obviously a Google group and the Confluence pages, and I can get you plugged into that. We've been trying to expand the library section on Confluence with presentations and recordings like this one. And there's a lot of work to go into that. In 2022, we really need to get better at creating, especially small briefings on specific tutorials and topics for people to be able to get at and come up to speed on different parts of this. So, but that work has evolved also since September. We have a number of new postings on there. Again, the topics of interest issues list has been updated, reprioritized, resolution work continued. The high priority ones, as you'll see, have to get resolved for the SDPi supplement 1.0. So it's really critical work, and my hat is, oh, I don't have my hat on. My hat's off to David and Peter especially for keeping those pieces moving forward. The Unity study was published. I have a slide on that, and the winners, they'll show you that, but the isolation point of care and silent ICU were two of the top use case value propositions that are in that study. A couple more items. We started the topics, oh, I already said this. Not only is the topics of interest updated and reprioritized, but also we have these two new topics of interest tables, one for the EP group and one for Madeira. How do those interrelate? So we've been working on that and the use of those tables. And then, of course, you also know from our IEEE updates on Tuesday that the PKP standards have been progressing, both the base 700, the metrics 701, and we're looking toward 702 work as well later this year. These are really critical for what we're doing in the SDPi world as well. I'll show you kind of the intersection between these two, but we're looking forward to participating in and seeing those successfully get published, hopefully later this year. And then also, we've talked on Wednesday, I know a lot about the Pocd-FHIR implementation guide. That continues with the addition of alerting support. And as we think about alerting, and we think about September 23 or a 23 showcase around silent ICU, the whole idea of adding FHIR support to that and being able to at least show alerts for analytics purposes is really important. So we're looking forward to that, as well as the integration of using SDC to FHIR, biceps to FHIR for reporting, and then the other direction, bringing in information, for example, patient demographics that might come from a FHIR source into an SDPi actor. So we're really excited about that work and hoping to see that go forward. Again, I mentioned the updated value of medical device interoperability study. Many of you saw this. It was published after, I think, October, November of last year. It included a ranking on various use cases. And you can see here the ones that came up at the top, like I said, isolation room. Go figure, during a COVID pandemic, but all the challenges around an isolation room, the value that is around that. See areas like digital charting and, but also quiet ICU was down there as well. Surgical displays. This is a different way of looking at that, where we look at the low to high around satisfaction and NPS. And one, as we said, was really out there. As a new area that had very high value. And then we see the quiet ICU also number 4 in that same quadrant up in there. So we're using that to help make sure we keep our charts, our sites set properly. If you have any questions on this, our good old friend Stefan is the one who championed this study and can get you a copy of that, or we can find the URL for that. It's around. This is a rework, by the way, of or an updated version of what we did at West Health back in 12 or 13 with Ken Fuchs and I around the value of medical device interoperability. Only this is a more global one, and it really focuses on these use cases. So very valuable, and it informs what we do on our roadmap and the work streams and how we prioritize that as to the value that's recognized, especially for those who use these technologies. So, as was reported in the last working group meeting, we have this roadmap. And the objectives and the work streams were pretty clear, okay? And we had these work streams we identified, going with what are the functionality targets that we're aiming at in 1.0, 2.0, 3.0. How does that then relate to developing the specifications, one work stream, conformity assessment and tooling, test scripts, integration with Gazelle, all of that, and then the computability and implementation support. So that's that requirements interoperability, model-centric, regulatory ready, and open source libraries. Another work stream being prototyping, pilots and demonstrations, education work streams, workshops, and then also foundational standards and support, working on both the devices on Fireside as well as the PKPs. So all of that was integrated into the roadmap, but what we did since last September was detail it out more. So we took these areas for each one of the core areas like 1.0 and said, okay, what are the specific use case capabilities that we want to identify? In that, I mean, if you look in the SDPi supplement, Appendix C, Volume 1, Appendix C, for the use cases, you have all these scenarios. Okay, well, we're not going to do them all for silent ICU, but we're going to do a set of those in 1.0 and then do another set of those in 2.0 and so on. So we subsetted those for use case capabilities. But then in the current version, we've updated SDPi profile specific capabilities. So for plug and trust, for reporting, alerting, and external control, how does the capabilities relate to those? Because it cuts across those horizontally. And then what about the related standards? How do those requirements relate to the standards that we want to actually leverage? So as I said, for example, PKP standards, how do what we do with this roadmap impact what we need out of those? When are we adding features to which of the gateway interfaces? And then finally, what are our targets in the parallel with this RIMCRR support? So we've expanded it, we've detailed it, we've evolved it, and I think it's becoming something that will really help us guide our work in the future. But of course, job number one remains get 1.0 out as soon as possible. And that really is something that's the key focus of what we're doing here. Just a couple of more updates, general updates. Conformity assessment and tooling, as I said, David and everyone has been doing these plug-a-thons. We've had 2 since our last meeting here. And they continue to build both the community, new people are coming in, evolution of test tooling that would actually capture and be able to work on, provide reports. Open source implementations are evolving and new ones are being provided and coming to the table. Test scripts about how to actually test the transactions, which will ultimately end up into Gazelle for these test cases. That also has been evolving. So the plug-a-thon events have been extremely important, have been very good. And I think with that, David, anything else you want to say about that? I'm not going to go in looking at the URLs for the events, but any perspective from you?
Yeah, so not in particular. We typically make good progress on each of these events. It's mainly regression testing from the former plug-a-thons, and we have a test sequence defined that is mapped to SDPi transactions, and we do test them against different implementations, but also strive for doing that against actual devices at some point. So that's basically the only thing I can add here.
And we have, as I said, newbies coming, and we have a real diversity of implementations in terms of different languages and different platforms that they're operating on. So let's see, as I mentioned, we have the IHE Catalyst Study, which kicked off in earnest last November, I believe, and is ongoing, hopefully about to complete, which will inform our roadmap then, and specifically, what does that look like to get to connect-a-thons and Gazelle testing and product conformity assessment over the next 3 years. So that work is completing. And also, item 3 here, virtual profile-specific connect-a-thons remain a priority, like in that Catalyst study, and getting more toward 24/7 testing support. So it's not just IHE testing, same old, but it's like, no, we need something better. We want to be able to hold virtual connect-a-thons, schedule them when we want that, when it makes sense for everyone, as opposed to only doing it at the regular events, which, like I said, we're targeting in item 4, the IHE European Connect-a-thon, which is, I think, in September, and then maybe doing one virtual Connect-a-thon this year in 22 as well. So that work has been ongoing. And then also the prototyping, pilots, and demonstrations. As I said before, we're focusing right now on a HIMSS 23 silent ICU use case demonstration, but we have other demonstrations in education venues, especially in Europe, under consideration. So a lot of work has been included on that, which is really good. Any questions then about that? That's all I was going to say on the work streams in the 3-year roadmap. Okay, one of the areas that we talked about last September was the need to advance a discussion in what I call the SES community, safe, effective, and secure community, and we kicked off a new initiative that was proposed. There we called it the Regulatory Initiative, and it's all around regulatory submission ready. We talked about the challenges around the road again, the pathway to create an ecosystem of plug and trust products. Identified this here and proposed creating a Gemini SES regulatory initiative. But the R word was really challenging. And so we had to figure out something else. And actually in figuring that out, that helped us sharpen our focus on what exactly are we talking about. So that was actually very useful for many of us. And the need was clear, but getting this the scope and the terms of reference, that was a bit challenging. So we had a number of meetings since last September of some key leaders, like Costa and Isabel and Ken Fuchs and others from a couple of other companies, to just talk about what is this, what would it look like, and we identified various issues, and sometimes we discussed it at great length, but we did make progress. All of which to say, I want to announce this new Gemini SES MDI Group Ecosystem Pathway. That's the short term. EP is the even shorter acronym. The longer is a pathway to an ecosystem of plug and trust products. This is what Ken was saying when he said, okay, we can get all the technical specifications in place, we can do all the prototypes, but unless you're really looking at this other side of the pathway, we don't really have, we'll end up at the party with something there, but there's, the band isn't playing. So the participants of this ecosystem pathway group is the same as what we said last September. Those who are really focused on product quality, on risk management, liability, and regulatory affairs. Stakeholders in this area, not focused on the technical side as much as the process side. We take the proposal that was there, cross out regulatory, put an ecosystem pathway initiative, and we have a table that we actually generated, topics of interest table. I won't take time now to look at that in detail. There's a link right there for that table, but we'll use that same method to be able to capture what are those key issues. For example, one of the issues I think I mentioned down in here is for conformity assessment, both virtually and physically, device to device. So in a pandemic world, travel challenged world, we can do a lot of virtual testing. All the plugathons are fully virtual now. But providing care is very physical and very in the present with real devices, real patients plugged together. How much can we achieve a balance between those two such that this ecosystem pathway stakeholders say, yeah, we have confidence that it'll work? And what does that look like over the next 2 to 3 years? So charting that out is one of the issues that would be in the EP table of issues, topics of interest table. So we're going to build that out, and this group will work through those and build, put those pieces together. We have a Google group for this with an initial set of participants. We're going to start bi-weekly Zoom meetings Tuesday, February 1st. And then we have a Confluence page. It's under development like a lot of ours, but it's coming together, and I think it'll be a good home for the discussion. And a call for all the SES experts. You know who those people are. Some of them might be you, but those who are really focused on this area, I think they'll find these discussions extremely enjoyable and productive and useful, especially if you're really looking seriously at the implementation, productization of these technologies. So the group is off the ground, and we're moving forward, and I'm really looking forward to seeing how those discussions progress. Let's see, the Gemini SES MDI focus topics of interest ×3. So we started with just that one topics of interest table, which I think you've seen before. This is an example, and that yes, we would have used Jira if we could. We wanted to, and we just couldn't. And IEEE, by the way, the standard side uses SourceForge and GitHub tickets, that stuff, or GitHub issues. But this is how we're doing it. And we have the table, it's a Confluence table. Here are examples of the topics that are high priority. And each one of these topics then has its own page. We actually have one that's resolved. And once it gets resolved, we then take this process where not only do we capture it in this table, and by the way, prioritize it in terms of not only this, but also which draft or version, major version of SDPi do we want to have it in? When did we actually confirm that? So we do that. We have separate Confluence pages to capture the discussion and the ultimate resolution. Once it's resolved, we create GitHub issues with a link to the resolution here, as well as a link to where it'll show up in the SDPi supplement issues and content section. So we've talked about that before. This is going ahead as being very, very helpful. Yeah, Jira would have been nicer, but it's working for us. We also have one for a Madeira profile, a set of topics of interest table, taking the same process as above. And now we have this third table, as I said, around the ecosystem pathway issues that we want to identify and resolve. It's started, it's in place, and that's what we'll start to work through in our every other Tuesday meetings. But when appropriate, we can then link the resolutions to the other topics of interest tables. For example, maybe there's something that's be discussed within the EP that results in a requirement or something we want to make sure we address in the Madeira profile. So we would have a linkage there. But where else do they get done? Because in the SDPi and Madeira world, we have a supplement. And so part of the discussion that we will have within the EP community is what exactly are those deliverables and how do we want to integrate that with the topics that we resolve? So that's going to be an interesting discussion that we'll have with that group, and how these three discussions in issue resolutions, how we can integrate those in a better way. Then an update on the RIMCRR part. As we reported, this is our description of these three areas that are not specific content focused, but more how we go about it. How do we achieve requirements interoperability? How do we move from a document-centric approach to a model-centric approach? And how do we really achieve regulatory ready and come up with something that everybody can take and use in their submissions wherever they are internationally. So we've continued to refine that process. Very specifically, the near-term approach will continue, the near term being right now, using word styles, bookmarks, and links. That is what Michael Fahn showed you yesterday in his V2 Plus work, right? Where he starts, basically he takes a document, a Word document, which is what V2 is now, pulled the styles and everything out of it, populated a source of truth database. So we've done some testing on that. Michael sees that working very, being able to leverage that for this work here. So that's what we're going to do in the SDPi 1.0. Eventually we'll go to model-centric, but for right now we'll do that. But I wanted to point out now that it's become increasingly clear that the Center for Requirements Interoperability will be in the SDPi Technical Framework 1 Appendix B and C. Remember that Appendix B has to do with ICS tables. So it's for the specific foundational standards that we say we reference and support and are profiling. Those standards have conformance statements and tables in them. And so Appendix B will actually capture for each one of those standards the ICS table, if you will, and then show how do we address that. Do we address that within the SDC SDPi+FHIR technical specifications? So that's really kind of, when you talk about requirements interoperability, that's really the pivot point happens in Appendix B. And then Appendix C is our use cases. And for Appendix C, those are more the functional requirements. And so that will also show us linkages to how, like for example, in the silent ICU, all the different scenarios and steps, how those are implemented. So it turns out that for requirements interoperability, the real key focus area, especially in the near term, is on these two appendices. And I'm looking forward to discussing those and fleshing those out in detail, because a lot of times, for example, we'll have items, requirements that come from one of these foundational standards, and we say, okay, how are we supposed to implement that? Or there's 3 or 4 ways of doing it. We have to come to agreement on how we do it, or we have to say it's not something that's really focused on what we do here, but when it comes time to do a submission to a regulatory authority, for example, we need to know what is covered and what is not. So all those discussions will happen as we work through appendices B and C. For model-centric, I think no, I didn't say this in the September meeting. It was increasingly clear as we went towards the end of the year that it makes no sense to spend a lot more time in investing in both the use of RecEF and Gherkin for this SDPi work. Instead, we should really look at SysML 2.0. I give you the URL for where you can actually go and look at the documents. There's some great presentations there. But the maturity of SysML 2.0 and the reality of it, it's not something that's out there sometime, it's actually there right now. And the relationship of that with the groups that we're working with in this project, it makes no sense to delay moving in that direction. So expect to see that begin more in earnest, especially after we get 1.0 out of the SDPi supplement. Okay, I can talk more about that in the Q&A later, but that is a key direction for getting model-centric, migration to model-centric. And then regulatory ready, again, forming that ecosystem pathway group is huge for discussing, creating a community that can really discuss that and work through all the issues around that. So it's easy to say regulatory submission ready. It's a whole different thing about what exactly does that mean and what do we do together as a community so we end up in the next 2 or 3 years being able to actually achieve that. The IHE Catalyst Study will also address that from a conformity assessment testing standpoint and how that supports this as well. So that area has been going forward also. So I think that's kind of the general update in terms of the Gemini project. We have a couple of more topics that as we advance the FHIR roadmap, we want to get these in there as well. Hopefully not to distraction, but thinking down the road a bit as we go further up and further into the mountains of medical device interoperability. So that said, I'm going to pause and say, does anybody have any questions on the stuff that I covered in the general updates to this point?
Todd, can one quick, the prior slide, one quick clarification on the reference implementation or the requirements interoperability SDPi technical framework. Can you say again, Appendix B mainly covers what? I got Appendix C is the use cases and functional requirements, but could you remind me again what B is?
Oops, oh, shoot, I hate it when that happens. When I let up, hang on 1 second, John. Show you exactly what I mean.
Okay, so that would be those are that's where the ICS tables would be, I guess. Yeah.
Now notice I have this note saying we need to extend the scope of this, because when we did this originally, it was just profiling 11073. And so as you look down here, for example, you will see ICS tables, right? Such as this one here. This is a general ICS table from which standard? This is the Biceps 10207. I think I have this here. So the question here is, you know, for this is a general 1, 2, and 3, we'll add an SDPi profile section here, which will actually say this is where and how or if we actually meet this requirement. And then that'll have that link to where the different places, probably a one-to-many, where it is actually supported in the specifications. So we do this for the 11073. So again, for requirements interoperability, this is kind of the key piece. We have these foundational requirements. They have ICS tables. This shows us with the links to where we actually handle that. But what is also being added?
The SDPi profiles would be the elaboration of that requirement to the left of it, if need be.
Yes.
So the further constraint.
Yes. So this column. So in the version in the standard has support, right, and comments. So what we're saying is, no, we're getting rid of the support and comments, and we actually have an SDPi profiles. How do we meet that requirement, or do we? Because in some cases we may say, you know, it's out of scope, or there was no consensus. So that's the general approach. Does that make sense, John?
Yeah.
And this was part of our discussions with IEEE, by the way. Can we take these tables, duplicate them, add that column, and show that? So we have this for the 3 core standards. And then also, we also though have it for, hang on a second, the base PKP. So this one right here, and this is a bit in flux, so expect that. But for example, you would have these requirements. And David, I think in our last September update, those slides from there, you talked about your PKP update and how you're supporting requirements interoperability through that, but that it was in a bit of flux. So hopefully once this settles down, we will do the same thing. We'll take those tables, we'll put them in here, add the SDPi support, and have that discussion. And again, this is an SDPi, especially in this area, I'm sorry, an ecosystem pathway discussion, especially in this area, you know, because it's more around the quality, risk management, regulatory affairs kinds of things. When I ask questions, they'll be like, is this requirement in scope for SDPi or not? We might do that. And when you run the report out of this, it would say, for this requirement, for this standard, that's out of scope. You can't test it. It has to be provided separately by the implementers. David Grigorchuk, do you want to say anything to that around these?
Oh, not really. That summarizes pretty good. Maybe just a general remark on the ICSs. So we are still having some issues with the ICS tables. They're gonna change a little bit, I guess, in the future. So we have some open comments for the ICS layout. That's the one thing, and the other thing is that while the base PKP and the other PKPs will provide very sophisticated ICS tables, we didn't have those sophistication for the SEC core standards. That's maybe a little drawback, but as we all know, those standards are going to be revised anyway, and I think we will then also come up with updated versions of those tables.
Right. And that's why I asked in the IEEE section on Monday, I think when Martin was on Tuesday, when Martin was presenting, I said, because the Pocd specializations is taking yet another kind of look at how do we want to have conformity to this standard realized or expressed. So this Appendix B will take whatever it is that we're claiming conformance to and detail that out such as it is. It'll also include support for general concepts and capabilities. In other words, we'll have some general issues. So if there's some areas where we have to say, you know, this was just not something we could address here for whatever reasons, we'll have space in this Appendix B to talk to that. Just so it's very clear, and or if there's something that needs to get put back into a future revision, it'll happen here. And then the last one here, I think you'll find of interest, I also added in, is in the, I added this. It'll probably go to, this is a placeholder because once we get the Madeira spec, it'll be built on top of this. So it's going to put requirements onto this that we'll have to say this is how we do that requirements. So those tables that were in there. But also for the, if you know the PKPs, you know they at least notionally reference 80,001-1, although they do it for the 2010 version. But if you look at the 2021 version, fresh off the press, you'll see that Appendix A actually has, I got a lot of notes about this, actually has support for specific requirements. So you go down through this Appendix A out of that standard, and we would say, okay, how do we really support this in SDPi? Some of that'll happen in the PKPs, but if you want to use this and claim conformance to the requirements around 80,001-1, what does that look like? So I stuck this in there to at least have that discussion. And again, this is clearly more of an ecosystem pathway discussion. It's very clear some of this stuff has nothing to do with what we will bake into the technical parts of the product that we can actually do conformity assessment against. But this is where that requirements interoperability, really a key juncture for that, as I said earlier. And then I think the last part here is, as we know, Appendix C is the use cases, and this is where we have all of currently the Gherkin stuff that we've talked about. So these kinds of things. Okay, so standalone OR dashboard is this. Standalone OR cockpit is another one, and this is where we have these Gherkin specs. And this really drives the functional requirements. And we would have links from these statements, okay, from the scenarios or from the general, the background, the general requirements to where they are actually implemented or supported in the specifications. So, John, that was a long response, but there you go. Did I answer your question, John? Have too much length?
That's good. Thank you. Appreciate it.
Yeah. Let's see here. Yeah. Any other questions before we go further up and further in? Anybody know that reference? Everybody should know that reference. Anybody know that reference?
No.
No. Don't.
Well, you need
That's too bad.
Yeah, that's too bad. Yes, you need to read your C.S. Lewis Chronicles of Narnia books to your kids.
Oh, I'm surprised. I haven't read that.
It's in the very end, the last book. When they come to the end of their journey, Unicorn calls them further up and further in. Okay, so this is a part, Michael Fawn has some ideas. We talked about this last time, just kind of threw it out there saying, a lot's happened in the last decades of the evolution of this terminology, but also in parallel, all the other uses of terminologies like SNOMED, CT, LOINC, and others, RxNorm and other ones. And the tooling around that and the integration of that into health, IT, health informatics infrastructure. So what might we do to better address issues and problems around that, or make it better and more adoptable? So the proposal was that the co-chairs, my hand is raised, would get a project going and moving, but we were pretty busy with other stuff. But that doesn't mean the topic hasn't been on the mind, kind of in the back, like, what might we do in the coming years? And it's been on mine, and especially on Michael RTMMS Toolsmith Fawn's mind. And so he's going to share with us a little bit later when he gets back some of his musings around this.
I'm here.
Oh, you're here. Well,
I never left. Yeah.
Well, there you go. Shoot. I hope I didn't say anything about you that I should regret now. In your absence. So you said you had a few slides you wanted to share, just on some of your thoughts, your musings around this.
Sure.
Let me stop.
And let's see if I can get this to work. So hang on one second. I don't know where the buttons are. Does this work? And I'm sharing a portrait mode screen. So if it looks bad or too small or something, let me know and I'll do
It's a
something
little
different.
small, but I can read it. How's everybody else?
Yeah, I see it okay, but I'm on a fairly big screen and it's wide.
Okay. Well, so as you might have just noticed, the goat for this has been Dr. Todd here. So, you know, I was kind of, when we were thinking about it, talking about it just the last couple of days, my question was, well, what's the scope of this? Are we talking about just what makes it into an IEEE publications, RTMS, or how do I need to think about this? How do we need to think about this? And this is what Todd came back with, and I think it's pretty good. It's basically, it's a pretty big scope, you know, so basically the goal is, well, you know, we want to improve its implementation, maintenance, adoption, and use of the MDC terminology. And the thing that, you know, I was thinking about, the other thing that we want to include in there is nomenclature development as well. We want, you know, how does that change? Does it look different than it does now? And of course, the overall goal is interoperability. So kind of trying to keep that as the thing that's above all this. So thinking about implementation, maintenance, adoption, and use, I want to make it, in case you haven't noticed, I'm definitely not an implementer. I don't wear that hat. So when we talk about this stuff and we think about it, yeah, I'm got my hands deep in this stuff on a, you know, daily basis, but it should not be me doing all the thinking about this and deciding where this goes at all, even though I'm the one that is responsible for making a fair amount of it actually happen. So this is definitely going to have input from people who wear other hats than the ones that I do. So just thinking about it, so what does that encompass? Well, the publication, you know, what gets into an IEEE publication? You know, what's in it, what's not in it, and at this point, you know, there's a lot of stuff that is nomenclature related that's not in IEEE publications. And the question is, well, should it be in there or should it not be in there? And contrasting that with RTMS content, which right now is, you know, kind of everything we have, or it's attempting to be everything we have. So aside from content, you know, features and functionality of the tool. And then part of that is the facilitation of that nomenclature development. And I put that in there because one thing that, you know, used to be part of the earlier RTMS tool, which I haven't seen get a lot of attention or is not talked about, was the Rosetta functionality. So is that something, you know, basically getting different vendors together and kind of harmonizing their terminology? Is that something that we're going to see happen in the future? Right now, it seems like that sort of thing is happening, you know, not with the use of any tooling, but just happening in working groups that are developing terminology for particular device types, if I'm not wrong. So, and then another thing I put in there is minimizing the need, you know, I think that we want to minimize the need for expert human management. And that's, I want to clearly contrast that with the need for expert human content developers. Like, that's not going to go away. We're going to depend on people to develop content, but we want to move towards automation and, you know, established procedures and systems that are implemented in software to a large degree for taking care of the housekeeping and, you know, assigning new codes, checking, you know, is this term something I can use or not use when I'm developing terminology and that sort of thing. You know, right now, we've been dependent on humans for maintaining, you know, lots of information to make sure that codes go in the right place and all that stuff. And, you know, I'm looking at Paul Schluter here, obviously, and we want to plan for a day, you know, 10, 20 years from now, even when we have some turnover in who's available to do all that stuff. And hopefully we've got some computers that manage that stuff for us to a larger degree than we have historically had. So, and keeping on going with that, you know, do we want to focus more on being able to integrate with other tools? Obviously we do, you know, so which tools? And this is basically ask for which tools do we want to focus on being able to integrate with, and how does that look, you know? And so further on, like the thought is like, well, it would be great if we had, you know, an established, maybe more than one serialization format for nomenclature, rather than, you know, right now everybody's got different Excel spreadsheets that they all look different. Sometimes I get XML, that XML isn't consistent, that sort of thing. So I've started working on so a description, and I'm still working on it, of, you know, how do we get down to a really tight and usable description of what these serialization formats look like that we can use to exchange information between one place and another for MDC terminology. So headaches that we have now, there's the royalty-free agreement that we have with IEEE. It's a good thing. It allows us to publish some stuff on our TMMS without, you know, IEEE getting in the way. But at the same time, it leaves me with some headaches because, in third bullet point down, there are a lot of special cases. So, you know, in some places you get publication of co-constraints in an IEEE publication. Well, that's not covered by the royalty-free agreement. So it means I have to manage, like, well, which co-constraints can I show on our TMMS and which ones can I not? Because if it didn't get published in an IEEE publication, it's fair game. And there's a lot of that stuff. So having uniformity and having just basically reducing the number of special cases means it's less stuff that I have to deal with, that other people have to deal with, and it frees up more space to actually do more good stuff to expand the functionality rather than just handling all the stuff we have and all the special cases. So if you've heard me say it before, and I know a lot of you know it, special cases are the devil. So I'll stop here for just a second. Does anybody have any questions or thoughts so far? Okay.
Wait.
Yeah, go. Yes, speak up.
Go back.
Go back.
So
back?
John Gargiulo, I think you also have been on the pointy end of the RFA with IEEE, and I forget when. I mean, I remember the pain. That was like 10 years in getting that, at least 10 years, maybe more, getting that thing worked out. What are your thoughts about engaging this kind of discussion with them also? Because it is, and what is there a timeline with that, or a you know, does it turn into go poof at some time?
So the RFA that we have has been in existence for I don't know, 5 or 6 years, and it did take quite a while to get to that point. Only for us to, as we advance, learn what Michael was just saying, that it does somewhat limit what our TMMS has grown into and can be capable of, particularly from a process standpoint of view of growing the nomenclature, which we've kind of argued all along, but we were happy originally to be able to let users come in and get at this, you know, at least the 5 attributes that are listed. But it definitely goes beyond that now. And so I have initially mentioned something to Tom Thompson and trying to get a revisit of what that RFA includes and perhaps expanding it. My view has always been, this is personally my personal view, that one of the arguments that IEEE originally noted was that, you know, it's a revenue stream for them selling standards and that kind of thing. But in my opinion, you know, this particular standard isn't going to really make or break anyone financially. So, you know, I kind of am reintroducing that again. And in fact, the argument has been given that through our TMMS, it broadens usage and interest and actually helps IEEE-SA. So we'll continue to do that. We have to work in the constructs of they do own, IEEE-SA owns the standard, and we develop it in the auspices of that SDO. So we certainly respect that. As being a government agency, we have to do our due diligence to make sure we are not in any way, shape, or form breaking any of that. So we are starting, we're not starting, but we're actually at the point where with our TMMS version 2, much improved functionality, much improved processes can be put in place. We've learned a lot of things over the last 7 or 8 years on how to make that process better so that we can actually do something like a semi-annual and annual release of data and have it driven through the single source of truth, as Paul and many others will state, to get that harmonized nomenclature, which now, after 7, 8, 9 years, has really taken hold across many domains. PhD, POCD, IHE, other development organizations are coming on board to use the terminology. FDA is recognizing it. CIMMIT, you name it. Folks are realizing, what our mission was to get use of common terminology, regardless of how that's mapped behind the scene at a particular manufacturer. So these all come into play. One of your questions, Todd, was the time frame. I can't honestly give you a time frame because I don't have one yet. It's very initial discussion, which I hope to have more with IEEE, and in fact may invite some of you to join me.
Not like a 5-year agreement that then you have to renegotiate.
Yeah, I've learned to never put a timeline on this stuff. I thought the RFA would take about 3 months, and it took about 5 years. So I guess stay tuned and keep the cause. Yeah.
Can I ask that we take a more positive view on this? Because
I'm sorry. A more what
positive,
kind of?
a positive
Okay.
approach, rather than you're being very negative, and I don't think it's helpful.
Okay.
When we did this 10 years ago, this was something extremely new for the IEEE to run a standard as a database. We didn't know what we wanted. They didn't know what was needed. And so it was an experiment.
Yes.
And I think that what we should report to the IEEE is that as an experiment, it's been extremely successful. And it needs some tweaks to make it so that it can be widely used by IHE-HL7 for FHIR and all of these other, FDA and whatever, so that it's widely adopted. This can then lead to sales of paper-based standards and other things. And I think you should paint this in a very positive light. From the experience that we've now gained, then we should negotiate that it should be extended to the following aspects. And I listed some in H3. You can check that, and you can go with Michael to see whether this needs extending. But we do this in an extremely positive way to IEEE.
That's a good point.
I agree, Malcolm, and I think I guess my point of this is perhaps as we go through this discussion, right, and we kind of resolve down to this is all the good stuff. This is the stuff that could be better, and if we did this, it would really expand the ability to use this. So in other words, it's a very positive story. We would have something crafted that we could then message back and engage in the discussions with the IEEE about it. So I agree. My other question is, I think the previous slide, Michael. Yeah, so today all of us, and you especially as our representative on, what is it, the terminology authority? Or the...
Terminology Services Management Group.
Of course it is.
And also Universal Terminology Governance. Yes.
Exactly. It's being able to, we have increasingly, and this is a good thing, people say, okay, I'm doing this and this, and I want to integrate, device data. How do I do that? And they have tooling platforms that they use to manage, their terminology and their nomenclature. Does any of that rise to the fore in terms of, yeah, I kind of see people using this or using that, or is it kind of something where we'd have to go out and do more of a survey and understand what that would look like to then be able to?
Before we go there are one or 2 points, and I think Michael and I have talked about this before, but if you look at the overhead regarding the creation of a standard, the biggest one is turning all of the terms that we have captured on the RTMMS, now V2, into a Word document. And if we could maybe negotiate with the IEEE, where we say we freeze it at a certain point, here are our new terms, we'll look at them without all of the extra work required to generate an MS Word document, and then after balloting, you copy it back in again, would be extremely helpful. And then the other thing that I find, the systematic names, I've been able to turn them into something useful, for events and alerts, but for observation identifiers, I believe this community does an extremely good job in trying to ensure that there are no synonym terms in general. Whereas events and alerts, it's another game, and the systematic name can be helpful there. But what I wish I could do with art, and I've been totally enjoyed working with Michael and John and everyone else on it, it's an invaluable tool, but there's still more process streamlining and reduction of non-value add activities, of which converting it to Word and then back again, especially an amendment, where especially if you go to the extra trouble of I'll insert this there and that there, it's a lot of work, and I'm automating that out the yin yang. But I wish I could just say, hey, here's a group like dialysis. We have a very solid agreement on how to represent the data from these machines. We've worked very well with now 12 vendors, and I'd just like to, like once they get to the provisional state, it should be ready to review as a table and maybe introduction, but nothing more formal than that. But because we've already captured the essence of what we're trying to do. So that would be the one area. And I know the IEEE, even 10 years ago, John Gargiulo and everyone, was interested, could we get to a database? But as long as you have the Word document as a gatekeeper, it does slow things down, because it also forces, there are like 6 major devices I'm dealing with. They all are kind of end up being lockstepped and bottleneck to right around now where we're creating the ballot. It'd be nice to have a more incremental thing so that the groups that you put together and gather, when they're done, they're largely done, other than maybe a ballot review, but that they're not waiting for, say, work to complete in the infusion pump group or ventilators or ventilator mode. So everything speaks to the benefit of having a database and broaching the topic with IEEE, where we have something that's demonstrated to be extremely valuable to the community. Now, can we, without bypassing ANSI rules and all the good things about standards, but just streamline it? So that would be my one major comment.
I don't understand what you're saying, Paul.
Well,
I mean, we publish 101.1R with
but that's a lot of new terms.
me
That was a very
finish, please.
valuable
Let me finish.
rearrangement
Let
of
me finish,
pre-existing
Paul.
terms.
Paul, let me finish. We published 101R with an annex which describes the process by which we manage terminology through the database. So we've achieved that in principle.
Not the process when you're working with 12 vendors, typically on Excel spreadsheets, and capturing the new terms, achieving harmony. That's the non-trivial part.
Well, you should be doing it through RTMS then.
No, that's really hard. People like spreadsheets because there's a lot of additional information that vendors, clinicians, and others want to capture.
I don't think either of you are entirely wrong. You know, that kind of opens up part of the discussion that I wanted to have. And sorry, let me back up. I want to have that discussion. I'm not sure that we're going to have time to discuss all of the things about making RTMS and MDC terminology better in the future. The goal here is to basically put stuff out there, get people thinking about it, and I would very much like to have, it's going to require a lot more in-depth discussion in the future. So, you know, while there are specific things we could talk about, solutions to specific problems that might be laid out here, and there are going to be things that aren't in these slides that are also going to be part and parcel of improving the MDC terminology. But with respect to, you know, this, what we're basically describing here is the fact that IEEE is great because it's an authoritative source, and once it, you know, becomes an approved IEEE term, it's published, then, you know, people can depend on that. The other side of that is IEEE moves really slow, and it's a burdensome process to get new terms in there, and that's a problem for people. And so one of the things that, you know, and again, I'm spitballing, I'm kicking it around, but is there a way that we can both develop what's going on in RTMS and promote it as a more authoritative source? So for instance, you know, is there some way that we can turn RTMS into essentially a pseudo, or, you know, how do we give it as much authority as possible where, you know, you can go to RTMS and you can be assured that
it's defined, Mike.
terms there have, and
it's defined.
have gone through a consensus
Malcolm,
process
let
and that
Michael
sort of thing.
finish.
Right.
You know, because right now it hasn't. You know, terms get in there, they come out of a particular working group, they get in there, they're provisional, but that's nothing like what happens to terms when they go through the ballot process in IEEE. And my thought is, can we do something on our own, put a little bit more structure in there, widen the consensus groups before they get, so in that Annex H, we have an approved status, but we're not actually using it, you know? So what would it mean for something in RTMS to be approved? We're basically jumping straight from provisional to balloting it. Can we actually use that approved status in RTMS in some way that when people go to RTMS and look at new terms, and, you know, we've got some status that basically says this thing is fully baked and, you know, it's real and you can use it and you can depend on it almost as much or even just as much as something that you're going to get from an IEEE standard. And I don't know what the answer to that is, but, you know, my thought is that a pathway to making, basically fulfilling what's in that first slide is, you know, improving interoperability and improving the adoption and use of terminology. So
We spent a
Malcolm?
huge amount of time at a meeting going through and designing the process. And so I don't understand.
Process, the end point of that process was to get to IEEE. And the distinction I'm trying to make is to be able to
Right.
tell
It
people
was
that
a
what's in
process.
RTMMS,
No,
you can
it
go to
wasn't.
RTMMS,
It
and
wasn't that,
that's
Michael. It
authoritative.
wasn't that at all, Michael. What was described was the process. And the process was completely described, what steps were taken and what confidence you could have in the terms at each step. And yes, we had to dovetail into the IEEE process that they prefer to have a published standard at some point. And we
I
agreed that
understand.
at
Let
minimum
me
we could do one every 10 years because that's the revision cycle.
Yeah.
You know, but beyond that, we don't have to publish anything on paper. We can rely on RTMMS, and that
Okay,
process is completely described.
let me extend then. Let me give you some an example of one thing that we could be doing. So
we need to,
all of these co-constraints. Sorry, go ahead.
We need to time box this because we're
Okay.
getting to the end of the quarter. So, and David
Right.
has yet to come to the table. So,
So do we need to stop now?
no, 5 minutes.
Okay. So real quick on that, an example of the kind of thing that it's all a soup together. But for instance, all of the co-constraints that I'm talking about that haven't been published. So right now, what's the authority of those co-constraints that are associated to metrics? The only place they are is in RTMMS. So if we're going to push that into a validation engine, and then somebody comes back and says, like, well, where's the information? It's not standardized. It's not in an IEEE document. So why do I have to adhere to this? And there's nothing about these co-constraints we haven't talked about. Well, is that going to be part of what goes into the standardization, and it gets pushed all the way through to an IEEE document? And so it's questions like that, like, well, what's the authority of co-constraints? I mean, basically, we sort of have this agreement, but it's just kind of an under the table gentleman's agreement that, yeah, this is authoritative. But does it have real teeth? What can we actually tell people about that? And it's so, if you think about that in the context of what's the authority behind RTMS and how do we demonstrate that, or can we not? Those are sort of the questions that, at least in my mind, I don't have the answers that I want. So
here's one idea. Could NIST become an SDO? Now, I know internationally that's going to create maybe issues with BSI and
again,
others. But
having good ideas about how to solve these problems are great. I got 5 minutes, so let's just plan on having more meetings to talk about how do we solve these problems. A couple other things that, we're going to get into stuff where we don't have time for anybody to get upset about it, Paul. But there are some things that I think could change about what we're doing with terminology. So co-constraints, should they be balloted? And again, that could be balloted not at the IEEE level, but it could be balloted at some level below that, which is, RTMMS ballots. Same with tokens. I think that we could formalize a model for co-constraints. I think part of what would make RTMMS stronger was, so I've got a model and RTMMS runs on that, but have more people look at that model and actually develop it as a consensus model. Like, yeah, we all agree that this is how, at least, a few people that understand models get in there and look at it and agree that, yeah, this is how our terminology works. And for instance, if you look at FHIR, they have a pretty solid model, and it's a consensus model of how terminology works. So, and then things, and this is where some people might get upset. It's my opinion that discriminators should be for development only, that they should not be published, and instead we should be publishing all explicit, expand everything, publish it, they're all there. I don't think implementers should have to be thinking about discriminators. Here's the term, here's the code, good, done. So similarly, I think that the use of code blocks should be considered very carefully. And to that end, I think we should be tilting towards terminology being something that's computable and machine processable in favor of human readable when crafting what we give implementers to use. So, and it's a little bit different from, on the development side, yeah, human readability is helpful, but I think we should think about a division between what we use for development and how that gets done, and then what comes out the other end. This is what we give implementers, and this goes to, adoption. If people coming in have to go through the barrier of, for instance, understanding, does it matter that these codes are in a block? Well, no, I just have a table of codes and numbers. So, and the same thing with discriminators. Do I actually have to, expand these things on my own in order to use them? Well, no, maybe you don't have to do that. Maybe you just have a list of codes and it's ready to go. So, I'm done. 924.
All right, thank you very much. And of course, on each one of those, that we could have a good discussion that starts with, well, wait a second, I remember why we did that back in the day.
Yeah.
All right, thank you very much. And good food for thought that we, like I said, it's musings for the future. And we'll keep that discussion live.
Yeah, and again, please take all of that as spitballing and don't assume that any of that is my plan, and that any of that will happen without further discussion. So
I learned what that meant when I was substitute teaching at a junior high one time and writing something on the board at the front of the room. It's a bad visual. All right, thanks a lot, Michael, for wading into this. And then, as I said, last but absolutely not least, there's been hallway discussion about considering another additional messaging protocol or transport as an option to the web services-based one that we have in the medical device profile for web services. One of those, the use of gRPC with protocol buffers, is now really being seriously considered. There's informal prototyping in 2020 and 21. That was very encouraging. And then in the December Plugathon, it included the gRPC protobuf test track, if you will, which was, as I'm told by the amazing David, that it was a complete success. And well, how successful is it? It was blazingly fast. Okay, and so we're actually adding that into the roadmap as an option. I forget where it's at, and as an option to the SDPi profile at some point. So with that, you might more even seriously check out protostc.org. From what I understand, it's a creation of David. And with that, David, I think you have some slides, or you want to take the discussion forward?
Yeah, absolutely. Thank you for this kind introduction. So Protostc, it's called. So let me quickly share my screen. As always, there are some slides prepared, but actually I just reused the ones from a meeting back in 2021. Hopefully you can see my screen. From an ORANET strategy meeting where we talked about the transport layer the first time. This was the first time that I made it public, that there is something in the oven, and we are going to pursue another approach towards data exchange between resource-constrained devices. So yeah, what the heck is Protostc, and more importantly, why a new transport technology? We already have MDWS. So happy you ask. Well, it's straightforward. The answer is currently SCC is based on MDWS, which itself has been published in 2016, I guess. But even at that time was based on outdated standards. For example, yeah, HTTP 1.1 that has been released in 1999, DPWS 1.2 from 2009, actually for which the technical committee was closed in 2016, at the same time when we published the MDWS standard, with a pile of open issues and no prospect of getting bumped to 2.0. There are a couple of other reasons why, yeah, this is basically an outdated and stale profile, not used, not widely adopted anymore. And yeah, what else? When it comes to verification, it's getting even worse. So in total, MDBWS references about 150 standards. Some of them contradicting each other, unluckily. We would need like a lot of profiling to boil it down to something that is truly interoperable. And long story short is that verification is not an easy task. We all know that. And MDBWS doesn't positively contribute to this fact. Another suboptimal thing is that MDBWS is based on XML, and we all know XML never proved to be an efficient and effective technology for inter-process communication. And last but not least, and trust me in this one, I went through all of it. When I implemented SDCRI, it's pain in the back, and implementing the standards is just an experience. Let me put it that way. And it needs heavy work to get the implementations interoperable. That's what I also experienced throughout the Pluggathons that we conducted the last 2 years. So far, so good. In 2020, me and a colleague and meanwhile friend of mine ran a case study to challenge other more efficient and well-adapted technologies. And we ended up with gRPC, a protocol buffers powered, oh my gosh, remote procedure call framework that comes with built-in features like bidirectional streaming and compact data representation. And I briefly explain that in a minute. And gRPC is driven by the Linux Foundation as part of the Cloud Native Computing Foundation, and hence well known in the whole world. And now hold on to your papers, it's all open source. The product that we developed is also open source, or will be open source once it's published. It's currently in a prototypic state, as already mentioned earlier. It's called Protostc, and this one is based on gRPC over HTTP2 and fully compatible with biceps. So that means we have eventing, we have discovery, we have security out of the box, including OpenAuth because it's built in gRPC, and as well as the participant and message model of biceps, all covered by Protostc. So how does it work? Before I go over to Protostc, I'd like to briefly explain the main building blocks of gRPC. gRPC is based on protocol buffers, serialization format for platform-independent data exchange, efficient with an efficient binary encoding that isn't readable by humans, but can be transformed into a JSON-like representation so that you can make it visible to users what you actually provided as data, and you can use it in log files and so forth. gRPC, on the other side, leverages protocol buffers to enable remote procedure calls, that is to say, inter-process communication. And it's currently based on HTTP2, but will also be adapted to HTTP3 once it's published officially. There is currently a space where you can download the HTTP3 supported version, but it's not in a final state and has not been released officially yet. Protocol buffers and gRPC were developed initially by Google and later on brought to the public and published as open source project. They are no longer under control of Google, so they are the original inventors, but it's now hosted by different contributors in the public space. Then there is Protostc, the one that my friend or me invented or developed as part of our efforts to come up with a proper and efficient way of replacing MDBWS. It's twofold. We have a converter application that is outlined over here. And then there is the biceps XML schema, or you can just take any XML schema that you like to put into the converter, and the converter then transforms the XML schema into protobuf messages, and also has the capability of optionally outputting the programming language specific data model mappings. That is something that we develop on top of it. The output is baked into the proto model, which then provides the biceps participant and message model alongside with centralistic and decentralistic discovery, and all of that on top of gRPC services. And for the sake of brevity, and because I did not prepare a holistic ProtoSTC walkthrough yet, let's get down to the numbers. Looking at this table, we compared MDBWS against ProtoSTC in different directions. So first of all, if we look at ProtoSTC, it pulls in like about 15 new standards, opposed to MDBWS that comes with 150 reference standards. This is a little difference. We did some, and I will just blend in a graphic. We did some performance testing with an early Java-based implementation, so there is definitely room for improvement regarding the efficiency when we talk about like C++ or Rust implementations. And what we did here is that we used the SEC reference implementation and tested it against the SCIC reference implementation over ProtoSTC. And we can easily see that there is a high throughput, like 10 times faster and 10 times smaller than, or there is this thing layover, up to 10 times faster and smaller than comparable messages over SCCRI. This is only a very coarse-grained view on the whole thing. So typically there are options in SCCRI, for example, to compress data, which would then be resembling the size of messages that are transported over the network. So it's then resembling the ProtoSTC messages. But on the other side, if one wants to compress in SDCRI using XML, the only option we currently have is, because of lack of implementations of different efficient data representations of XML, using the deflate or gzip compression that is built in HTTP. So it needs another processor cycle or an additional processor cycle, opposed to ProtoSTC that directly from an internal representation of the data serializes into the network representation format. Other than that, we also compare discovery messages to each other, and we see, which becomes very important when doing the whole thing in UDP, is that, for example, for a hello message in MDBWS, we used 1,000 bytes on the network, opposed to ProtoSTC that only needed about 130 bytes to convey the same information. And some other things that definitely should show that there is a favor for ProtoSTC, just because it's so much more simple and it's maintained by a huge community. All of that, it's not the case for MDBWS. But let's get back to reality. So MDBWS is far beyond the point that we can kick it out and replace it with ProtoSTC. We cannot just throw away the effort that we put into MDBWS throughout the last decade, so to say. So especially because ProtoSTC is only in a prototypic state so far. For example, we haven't fully solved the mapping of XML extensions to protobuf extensions yet. I'm pretty sure we can also manage to do that, but still something that is open and has not been solved yet, mainly because we all did that in our spare time. So I was not paid by Draeger, just for your information, to create all that. Plus, in contrast to ProtoSTC, MDBWS is an IEEE standard and also recognized by the FDA, which is currently not the case for ProtoSTC. But in short term, I think we can finish the proof of concept of ProtoSTC, and then accordingly, as already mentioned by Todd, push it to SDPi, first as a topic of interest and later on as an option, as a transport option eventually. And then sometime in the future, that's the big picture, we can also bring Proto-SDC to the IEEE, either by revising the 2701, which is the SDC glue standard, or just by coming up with a brand new standards number. That's up to the future. But short term is definitely focusing on the Proto-SDC option in SDPi. Yeah, and that's in a nutshell. So what we're currently working on is a website that shows the Proto-SDC logo that I'm very proud of. And if you want to get started with Proto-SDC, you can visit this page and you can press Get Started and then see an introduction followed by a quick start. And quick start is basically what you need to ramp up your application and get in touch with the Proto-SDC implementation, which should be pretty straightforward once you read through this quick startup. It will also, in the near future, list architectures, including the documentation that we are going to write for the proto converter and the proto model. We already set up dedicated websites, documentations for both applications that are part of the Proto-SDC framework. That's it. Thanks for the attention, guys. And yeah, if you have any questions, I'm not sure if we have time for questions. And
well, yeah, I have a couple questions, and then I think we're almost done, by the way, John Gargiulo. I know we're past the quarter end, but I think just 5 more minutes. So what about separating these? I know some have said, well, what about just using protocol buffers, but not gRPC or some other combination?
Yeah, the answer is pretty simple. gRPC itself has a tight coupling to protocol buffers, so it all comes from one vendor, so to say. gRPC incorporates incorporates protocol buffers, so there isn't really. So you can pull in protocol buffers and try to tie it to MDPWS, but then you would need the whole infrastructure that has already been implemented by gRPC that you then have to separately implement as part of the existing frameworks, and then do the interoperability testing to just prove that there is a possibility of binding protocol buffers to gRPC. On the other side, having gRPC that provides all of that without any additional testing. So we can just start walking without learning it again and again. And that's the reason why it's theoretically possible to do it, but it's economical nonsense.
And I think the last point I'll point out, make here is just anecdotal. When Todd's super secret software engineering son number 3 kicked the tires on gRPC protobufs, and he does work in a military secret cubicle area. I forget what they call it, SCIF, I think. I forget what that stands for. He says usually whenever he goes to get a new set of tools put up on the server that he can access, it takes months, even if it's widely used and stuff. He said when he actually asked them to put the core pieces of this stuff, gRPC and protobufs on that server for him to start using, it took about 5 or 10 minutes, which meant from a really tight security perspective, this stuff is really solid and has been vetted. So that was interesting. And I think also in your slide about who supports this, a lot of other companies also do. So I think and at least support it or use it, and it's embedded on a lot of mobile platforms and things like that. So getting out past just the acute care context, but other uses of this, this is a clear, open, easy way of achieving that.
Absolutely, I would totally second that. So and that is my experience with gRPC over the last 2 years, is that it easily integrates in everything. So you can just set it up with your favorite programming language and it just works, which is nice because it puts our work into another perspective where we can focus on our medical issues in terms of the medical devices, obviously. not our own health, and get away, get a distance to the technical part of it, which is also important, but shouldn't be our deal. So it's more important to focus on what we are doing, where we are the experts in, and it's definitely not remote procedure calls.
Yeah, yeah.
My closing
All right,
words.
thank you very much, David.
Thank
Does
you.
anybody have any questions specifically about this? All right, and does anybody have any just general questions about this program update and the topics that we've gone through over this last hour and a half plus?
This is Paul. I have one question for David. You know, one aspect of medical device communication is that you can plug modules in and out. That is, in a highly efficient protocol, what you're sending can change infrequently, but it does change. And that's often a weakness of some high performance protocols. And so I think it would be important to be able to support the ability that if somebody plugs in some new modules, that can be seamlessly inserted into the current ongoing data stream. And
yeah, so
we can discuss this offline, but you know, I'm interested in that.
Yeah, totally.
Okay.
So short story is yes, but we can definitely elaborate on this offline. Thank you.
All right.
But that's really important, Paul. In reality.
Oh yeah.
You know, when you go to actually put this stuff in a point of care, that's reality.
Yeah. Yes. Things change.
Yeah. All right.
Okay.
Anybody else?
Thanks.
All right. Well, thank you everybody for your patience. You know where to get a hold of us. We have regular weekly and bi-weekly and a few times a monthly meetings. And if you have any questions, just let us know, and we'd love to